Here the displacement of the particle is described by the equation x1 equal to a cos omega t plus pi x. When the particle crossing the mean position, then the displacement is 0. So this is x1 is 0, so this is x equal to a cos omega t plus pi by 6. Now cos omega t plus pi by 6 equal to 0, and we know that the value of cosine is 0 when this is the odd multiple of pi by 2. So here n equal to 1, 3, 5. So comparing both sides, so omega t plus pi by 6 equal to n pi by 2. So for smallest value of time, we take n equal to 1. So this is omega t1, let's say time is t1, plus pi by 6 equal to pi by 2. So omega t1 equal to pi by 2 by pi by 6. So this is pi by 3. So t1 is pi by 3 omega. This is equation 1. And for second particle, and this described by the equation x2 equal to a cos omega t plus pi by 3. So when it is also crossing the mean position, x2 is 0, so 0 equal to a cos omega t plus pi by 3. Now cos omega t plus pi by 3 equal to 0. Now we know that the value of cos odd multiple of pi by 2 is 0, that is n equal to 1, that is cos pi by 2, and this is also 0, and n equal to 3, that is cos 3 pi by 2, this is also 0, and so on. So for smallest value, so comparing both sides, this can be written omega 2 plus pi by 3 equal to n pi by 2. So for smallest time, here we also take n equal to 1. So this time is written as omega t2 plus pi by 3 equal to pi by 2. So omega t2 equal to pi by 2 minus pi by 3 equal to pi by 6. So t2 equal to pi by 6 omega t2. So the minimum interval of time, that is time interval, that is t1 minus t2. Here the value of t1 is pi by 3 omega and t2 is pi by 6 omega. So interval, let's say del t equal to pi by 6 omega. So option D is correct.